Okay, today's lesson is on factoring quadratic equations. We're going to break this into two parts to keep it from being too long. The first part, we're going to do a quick review on quadratic equations, what factoring is, and we're going to talk about where the leading coefficient, the number in front of the square term, the square variable term, is equal to 1. And then we'll do another shorter one on where the leading coefficient is not equal to 1. So let's do a quick review here. Remember, a quadratic equation is in the form of ax squared plus bx plus c, where a, b, and c are numbers. Okay? An example would be, for example, say 3x squared plus 12x minus 7. Okay, now that is a quadratic, and notice that the first term is 3 here, which of course is not equal to 1. Another case that would be equal to 1 would be x squared minus 5x minus 35. Well, let's see, let's make it 14, right? And that would be a case where a is equal to 1, b is equal to 5. This is a equals 1, b equals 5, and c equals minus 14. Actually, minus 5 here. Okay, so those are quadratic forms. Now, when it's in this form right here, we call this the standard form of the quadratic. In the standard form of a quadratic or any other higher order polynomial equation is where you list the variable with the highest exponent first. So you can see we have x squared. Let me change here. So we got x squared first, and then of course this is actually x to the 1, but we don't write the 1. And the c term is merely a constant. Okay, it's a number or constant. But in reality, it's actually x to the 0 power. X to the 0 power is 1, so we don't write that. And so that's the standard form. Now, before you factor a quadratic, you always want to put it in the form where what we call standard form, which is the ax squared plus bx plus c. So if it is not already in this form, you want to put it in that form before you start. Otherwise, the conditions that we need to make to do the factoring using A, B, and C as a part of our process will be in the incorrect places. And it also could affect the sign. So you always want to SIGN sign, so you want to make sure it's in this form before we start. All right, now what are the conditions that we need to meet to do a factoring process? First of all, let's think about a quadratic and what factoring is. Factoring is the opposite of foiling. Right? So let's just take a situation. Let's start with two factors, and you've been taught how to FOIL those to get a quadratic. So if I have x plus 7 times x minus 5, and if I do that, remember what FOILing means. It means first, outer, inner, and last, right? So if we follow that process with these factors, we multiply the two first terms together, this one and this one, we get x squared. And we multiply the outer terms, x and minus 5, that would be minus 5x. And we multiply the inner terms, plus 7x. And then we multiply the two last terms, 7 and minus 5, minus 35. And then when we collect terms, we're going to collect the minus 5x and the plus 7x, and we get the final answer here, x squared plus 2x minus 35, right? That's the quadratic equation we get, and you can see that is in standard form, ax squared plus bx plus c, where x, the first coefficient, a equals 1, b equals 2, and c equals minus 35. All right, and so that's in standard form. So when we factor, we start here, and what we end up with is the two factors. And if you FOIL the two factors, you get your equation back. So that's why we say it's the opposite of FOILing. Okay. Now, what conditions have to be met when we factor? Okay. Well, let's take the examples. We'll use the same example, or let's just first of all let's take the generic example again: ax squared plus bx plus c. Now, we want to find two variables that meet a couple of conditions. And you can call these two variables anything you want, right? We could call them A and B, M and N, P and Q, R and X, whatever you want to do. But we just pick names because, after all, variables are names for a missing quantity, and you can just name it whatever you want to. So let's use P and Q as our two dummy variables. And the conditions we always want to meet when we find factors is we're going to find these two variables. We want the conditions to be met that P plus Q equals the B term, the B coefficient. We also want P times Q to equal A times C. Okay, so P plus Q equals B, and P times Q equals A times C. Now, what we're going to do today in this one is we are going to use the condition that A equals 1. Okay, so if A equals 1, then P times Q equals 1 times C, which is equal to C. Okay, so we can drop the 1, or we can drop the A term if the A coefficient is equal to 1. All right, so then in that case, P times Q is equal to C. So therefore, P times Q equals C for the simple case where A equals 1. Okay, and so that's what we're going to look at. So this is where we're going to concentrate on this next set. All right, so let's take some examples. And let's take x squared, and we'll do something fairly simple, minus x minus 72, and we're going to factor this. All right, so the easiest way to do this, if it doesn't just jump right out at you, to pick the right numbers, let's go ahead and do this. We want P plus Q to equal minus 1. That's the B term, right? Here's the B term. And then we want P times Q to equal minus 72. And if this, like I say, if this doesn't just jump right out at you, which the more you do this, the more you will have a tendency to do that, what we can do is we can say, all right, let's make a little table. And we'll take P and we'll take Q, and we can say, what are some factors of this minus 72, and then what do they add to, right? So some over here, and most of this you can actually probably do in your head, but what are some factors of minus 72? Well, we know that from your times tables that 6 times minus 12 equals 72, 12 times minus 6 equals 72. Some other things we could do, let's see, how about 9 times minus 8, or minus 9 times a positive 8. Okay, so 6 and 12 add together to give me That's a minus 6, right? So that doesn't work. If I do this, I'm looking for minus 1 here, and this would be a positive 6. That doesn't do it. 9 times minus 8 gives me a positive 1. Minus 9 times 8, gives me minus 1. Guess what? That's what I need. So I can stop there. I don't have to keep finding factors, just doing that. So now I know that P and Q, doesn't matter which is which, P is going to be minus 9 and Q is going to be 8. And so I just merely transfer this over to the factors that make this true. And so I can say that x minus 9 times x plus 8 is going to be my solution. All right. Now, do I know that for sure? Well, if I really want to try, I can FOIL this. And if I FOIL it, I should get my original equation back. So let's do that. So first term's x times x is x squared, x times plus 8, and minus 9 times x, and minus 9 times plus 8. Okay, and then collect terms, x squared minus x minus 72. And there we have it. Okay, and so it works. So that's the process. So let's do a couple more just to make this come home to roost. And what do we have? Let's see. Let's try a squared plus 7a plus 12. Okay. So again, let's go over here to meet our conditions that P plus Q is going to equal 7, and P times Q equals 12. And so what will make that true? Okay, so let's find some factors of 12. We want that to happen. And so what happens here? P times Q, what are some factors? Well, 1 and 12, obviously. We could have 2 and 6. We could have 3 and 4. And that's pretty much it, I think. Okay, so when we sum these together, okay, what we want 7, right? We want 7 to be the sum. 1 and 12, well, that's 13. 2 and 6 is 8. We're getting close here. 3 and 4 is 7, right? And I want to show you something. I'm going to do this problem again, but with one changed sign, just to show you what will be done. But before we do that, we know that our two numbers that we need now are the 3 and 4, and so I can factor this into a plus 3 times a plus 4, and those are my two factors. And if you FOIL that, I'm pretty certain you'll get a squared plus 7a plus 12. Now what happens if, let's suppose that we had, and I'll just duplicate this thing, we'll just do it again, a squared. What if I had a squared minus 7a plus 12? Okay? So what happens here? Okay, well, we still want, first of all, we want P plus Q equals now minus 7, and P times Q equals a positive 12, okay? Now, how do we treat this? Well, if we have P and Q here, and we already found that 12, one of the ways that works is like 3 and 4, but we want, in this case, we wanted a minus 7 instead of a plus 7 for our sum. How can I get a positive 12 here but add together to get a negative? Well, what we know is that a minus times a minus also gives me a positive. So that does give me a positive 12, and guess what? It gives me my minus 7 over here. So when you're working with factoring quadratics, kind of keep an eye out for situations like this where your middle term may be minus, but your end term is a positive, right? This a minus is a positive, And the only way I can get a positive multiplication is using two negative terms, and the two negative terms will add together. So when I factor this, I would have a minus 3 times a minus 4, and that would be my result, okay? So that goes over there, right? All right. So that's factoring where the leading coefficient, the a term of the quadratic, is equal to 1. And as you do more of these, you'll find that this process right here, okay, this process will become easier. You recall your times tables, and you'll be able to quickly find the terms. Let's just do one more, and then we'll end it. All right? Let's suppose we have, let's see, r squared plus 3r minus, let's say 70, right? All right. Now notice we've kind of flipped on this one. We have a positive term in the center and a negative term at the end. Well, the only way we get a negative term as the end term here is if one of them is positive and one of them is negative, right? Because if they're both positive, I'd have a positive. If they were both negative, I would have a negative. So what we have, we've got P plus Q equals a positive 3, and P times Q is equal to a minus 70, right? So do our little table, and what are some factors, all right? Excuse me. All right, well, we could do 2 times 35, and I could do a minus here and a positive here. I could do minus 2 times 35. I could do, what else? Let's see, let's say 7 and 10, where the 10 is a minus, or I could do minus 7 and plus 10, and there's some other ones probably, but just looking at the factors here. So what is my sum? Okay, we want it to be 3, and 2 and 35 obviously is not it, and minus 2 and 35. 7 and minus 10 gives me a minus 3, and minus 7 and plus 10 gives me a positive 3. And guess what? That's what we're looking for, right? The positive 3. So my factors that I'm going to use for factoring this are going to be minus 7 and 10. So I can come over here and I can say x minus 7 times x plus 10 is my answer. And this is just for the fun of it, we'll FOIL this just to see what happens. And so we'll have x times x is x squared. We have x times plus 10 is plus 10x. And minus 7 times x is minus 7x, and then minus 7 times 10 is minus 70. And when we collect terms, we'll get x squared plus 3x minus 70, right? How about that? All right. So what we'll do is a part B, which will talk about factoring quadratics where the leading coefficient is not equal to 1. Okay? And that concludes this presentation.